Welcome to 10 Minute CS. Today's problem is longest subarray with maximum bitwise AND. So we are given an integer array nums of size n, and we have to find a non-empty subarray that has the maximum possible bitwise AND. So let's see, for this example, if we will see the maximum possible bitwise AND of a subarray is 3, and the length of that subarray is 2, which is 3, 3. So with a brute force approach, we can find all the subarrays and find the bitwise AND of that subarray and find and get the maximum length of that subarray. So let's say n is the length of the subarray. So we can initialize our maximum bitwise value with the maximum element of that subarray, because the subarray for every subarray of length 1, the maximum AND value will be the maximum element value. So let's say we have this subarray and we need to find the maximum bitwise of all those subarray which has the maximum length as 1. Then the maximum bitwise AND will be the maximum number itself. For in this case it will be 3. After that, we have initialized a maximum length to 1, and we are looping over all the subarrays, and then for each of those loops we have initialized our AND with the element itself, and we are using this property of AND of the number with itself is the number itself. So, and for that the length we will calculate the length of all those subarray with j minus I plus 1. So let's say our j is pointing to index 2 and our I is at index 0. So 2 minus 0 will be 2 plus 1, that is 3, which is the length of that subarray. Then we will see if our maximum bitwise AND is lesser than the AND we have just calculated. If that is the case, then we should update our max to the current AND and our maximum length to the length calculated just now. If it's not true, that means that our maximum AND is either less than or equal to AND. In the case of less than, then there is no need of updating the maximum length, because we need to find the maximum length of the maximum bitwise AND. But for those cases when it is equal to AND, we need to fetch whether the length previously calculated was lesser than the length now we are getting. If that is the case, then we should update our maximum length variable and finally return the maximum length. For this approach, our time complexity will be, we are using big O of n here and big O of n square in these loops. So our time complexity will be big O of n square, whereas our space complexity is constant. Can we do better? Yes, we can. So if we see our key properties, for every non-unique 2 elements, the AND we are getting is strictly less than the maximum of those 2 values. That means our AND is always decreasing the values of our elements. So if we think of it little bit, that means that for any numbers which are non-unique, that means the AND value will be lesser than the number itself. Let's say we have 3 and we have 3 and 2. So the AND of this will be lesser than the one element, which is 3 AND itself. So the only case which is left for us is we need to find the subarray which has all the elements equal to our maximum element. Then only the bitwise AND will also be maximum and the length will be the maximum length of that subarray. So our problem is reduced to finding the subarray which has all numbers equal to the maximum number of the subarray. And finally, we just need to return the maximum length of that subarray. How we're going to code it? We'll just find the maximum number in our element, and we can run a for loop over the length of our array, and for each time we are finding that our number is equal to maximum, we have to increase the count, which is the current length of the subarray, and we have to update our length, which is the maximum length, to whichever is greater, either the current length or the maximum length. And if we are not finding the element not equal to maximum, then we just update our count to 0 itself. Let's have a dry run over this problem with a sample problem itself. So after running this for loop, our maximum will be updated to 3. And with this for loop, let's say our count is initialized with 0. So as our nums is not equal to maximum, which is 3, so we will just keep on skipping until we reach a number which is the maximum value itself. So at index 2, we find that our element is equal to maximum, so we will increase our counter to 1, and we will update our length to the max of those two. It was initialized with 0, now it will become 1. Now we go to the third index and we see that it is again equal to maximum, so our count variable will be increased to 2, and our length variable will also be increased to 2. Now we'll go to our fourth index, which is 2, which is not equal to maximum, so we will again initialize our count variable to 0. Similarly, we can go to 2, and then again it will be 0 only, and finally we are end of loop, so we will return our length, which is 2. Now let's say it was not this but a bigger array. Let's say we had 3 3 3 here again. So now at this point our count would be 0, so we will increase it to 1, and then at this point we will increase it to 2, and at this point we will increase it to 3 again, and we will see that the length variable will be equal to maximum of length and count, which is 3, 2, which will be 3. So we will increase it to 3, and we would have returned 3. So the time complexity of this problem will be big O of n, as both of these loops are going till the last of the array element, and the space complexity is constant. Thank you for watching.